Hello, my name is Jake Valentic, and I am a computer science undergraduate student at the University of Michigan. This video shows the research project I did during the winter 2011 semester. It uses ARToolKit to identify and track parts during a manufacturing process. The project's purpose is to make sure a robotic assembly arm places different parts in the correct order. It does this by identifying distinct markers using a camera and ARToolKit. ARToolKit is a software library designed to identify these visual markers using a camera. It was developed by the Human Interface Technology Lab at the University of Washington and the University of Canterbury in New Zealand. The first part of my video shows what happens during a successful construction, meaning all parts are placed in the correct order. Here I start the program, and in this window you see what the camera sees, along with a sphere drawn on the base to let you know that it has identified a base marker. Over here are each of the separate parts waiting to be placed in the plastic box by the robot. And now for the base markers, there are 3 of them. And when the pallet comes around the assembly line, the program first checks to see what base marker is there. And based on one of the 3 base markers, it will set in the program what order it's expecting to check the parts in. So the first order with base A checks for C, D, F, and G. And you just saw it place C first, and the program identified it successfully and sent a message that said it was placed successfully. Now the next part, D, has been placed, and a blue box is drawn on it just to let anyone who is looking at the laptop know that the part was identified. And here F is placed. And finally G is placed, and the program lets you know that it was placed successfully. And now when closing the program reports that all parts were placed in successful order. The next portion of my video shows an incorrect order being placed into the plastic box. The order of the parts waiting to be placed is C, G, F, and D. Basically, it's different from the first part of the video in that G and D were switched in their places. Now C was placed first and it was identified, and C is the correct first part that should be placed, so the program reports that it was identified and placed successfully. The next part up is G, and the program reports that it was placed incorrectly because G is not the part that is supposed to follow C. And now F was placed. While F does go in the 3rd spot, It was placed on top of a G, so that is an incorrect placement because it isn't supposed to be placed on top of a G. It's supposed to be placed on top of a D. And then finally D is placed, and it is reported that it's placed incorrectly because it should not go last and it should not go above an F. When I close the program, it reports that the assembly was built incorrectly, and it reports which parts were placed incorrectly as well. This information can be sent back to the manufacturing line so that the problems can be self-corrected, or it can be sent to some kind of monitoring station where a worker can identify the problem and fix it. Special thanks to the people that helped me with my project and answer questions when I had them. And thanks for watching my video. I hope you enjoyed it.